Respected chair, co-chair, organizers, and participants, hello and good morning. My name is Saad Mahmoud Soni, and I have a bachelor's degree in electrical and electronics as well as a master's degree in RET, Renewable Energy Technology, from the University of Dhaka, Bangladesh. I've been working as a plant and project engineer for the past 7 years, so I'm primarily responsible for the utility sector, plant maintenance, and project management. On behalf of FSQ's Engineering Education, I'm presenting this presentation. I'm really sorry that I couldn't present this presentation live. I'm going to talk about waste to energy incineration for the pharmaceuticals industry for the next 10 minutes. This work is based on my experience in working in the pharmaceutical sector. Background of our work. Why incineration is important in pharmaceuticals industry. Before talking about this importance of incineration, let me give you a brief idea of the incineration process. Incineration is a waste treatment process that involves the combustion of substance contained in waste materials. Incineration is a waste treatment system that is described as thermal treatment. Incineration converts the waste into ash, flue gas, and heat. Incineration reduces the solid mass of original waste by 80 to 85% and volume by 95 to 96%. While incineration does not completely replace landfilling, it significantly reduces the necessary volume, volume for disposal. Incineration has particularly strong benefits for the treatment of certain waste types, such as clinical waste and certain hazardous waste, while pathogens and toxins can be destroyed only in high temperature. Thereby, incineration is a mandatory requirement for pharmaceutical industry and healthcare facilities. Thereby, due to all outdated and expired damage, QC failure, or unwanted control, drugs should be destroyed to prevent the possibility of any unwanted medication or drugs to be shipped out from a pharmaceutical industry. We need to do incineration, and as pharmaceutical waste is quite hazardous, due to significant health, environment, and biological safety issues. It is as it is far different from the regular waste, and therefore special measures are required to dispose it properly. Thereby, we use the incineration process. Let us come to our third slide, where we are talking about typical incinerators that we use in the pharmaceutical industry. Let me give you a brief discussion on this. From here, we are feeding the waste into our primary chamber. Primary chamber is the chamber where we all the waste will be loaded and incinerated for the first time. Volatilization of waste is primarily achieved in the primary chamber through a burner and to controlled air. The ash will be that after conversion of waste into the ash, the residue will be retrieved from here, and the volatile gas and moisture that will be coming out from the primary chamber will be then go to the secondary chamber. In the secondary chamber, we keep it in higher temperature than the primary chamber. It usually stays between 1050 to 1050 to 1150 degrees Celsius, and the result of that will be coming out from the secondary chamber is flue gas, and excess air are utilized in the secondary chamber. In the secondary chamber access to the volatile gases in the primary chamber to complete the combustion process. Some of the gaseous products are completely oxidized in the secondary chamber due to sufficient resident time, high temperature, and 100% excess air. After the gas leaves the secondary chamber, they are treated. The gases finally enter the droplet separator, wherein the moisture is removed from the gases. This reduces the flue gas temperature, making it safe to be let out in the atmosphere. Let's go to our next slide. Here we are discussing about our main objectives. Our main objective is to propose a model to categorize the different type of waste produced in the pharmaceutical industries and to estimate the amount of waste produced in the pharmaceutical industry from that model. Here we have categorized the waste that we will be we may be having in the pharmaceuticals industry. The categorization is based on their type, their characteristics, and we have given some examples. And here we have talked about their state, and their calorific value is given in this column. Next, we'll be going to our next slide. This is our case study. And we have further talked about the waste. This categorization is based on the waste that will be coming out of different manufacturing process and different activities from pharmaceutical industry. Here we have talked about the state of the waste, and this column represents the waste of the waste in weight, and this column represents the waste of the waste weight of the waste in per month. Our next slide is about the calorific value. We have provided the calorific value of solid medical waste here, liquid medical waste here, and this is the calorific value of diesel fuel, and this column represents the value of all this the waste type and the diesel fuel, and this is the ratio of the mixture, and we have used the calculation. We have done a calculation to find out the calorific value of the mixture, and it was found as 5,427.542 degrees centigrade. Our next slide talk about the workflow of our proposed model. From here we are feeding the waste in the bottom chamber. This is the representation of the dual chamber incinerator. This is the upper chamber. The flue gas will be coming out from the upper chamber, and this is the incineration exhaust. The temperature from thermal energy from these two chambers will be utilized to generate the steam here, and we will be going to our next slide. This is about our schematic representation of our proposed model. Here we have provided the schematics that we will be using to convert our waste, the thermal energy from our waste to generate the steam. Here we are feeding the waste. Here will be here the controller will be entering into the primary chamber. From here we will be burning the waste from this burner. The temperature of the primary chamber will be stays within 750 degrees centigrade to 850 degrees centigrade. This configuration represents the water tube configuration. This configuration will be utilized to generate the steam, and from here the volatile gas and mixed moisture will be going to the secondary chamber. The secondary chamber also has some tube-like structure like the primary chamber is having. This will also be utilized to generate the steam, and finally the flue gas will be discharged to the environment from this chimney type structure. And now we'll be going to our next slide. Our next slide is the representation of the energy output that we'll be getting when we are incinerating the waste. Here we have utilized the data from the steam table to have the steam exact steam pressure in the adjacent temperature, and this is the enthalpy of the saturated steam. This is the enthalpy of feed water, and we have considered the efficiency to be 70%, and when we utilize all this data, we are getting the capacity of our boiler that will be generating the steam while the incineration process is carrying out. The capacity was found as 1689.94 kg approximately. This slide is actually a brief summary of the results that we found after doing all this calculation. Here we have represented the steam related data. These are the parameters. This represents the temperature. This is the pressure representation. We have considered the efficiency as 70%, and the generation capacity was found at 1689.9. This was the capacity per watt. This is the representation of this column represents the fuel save. This is the representation of daily savings in kilogram. This is the representation of monthly saving in kilogram. This is the representation of yearly saving in kilogram. This is the carbon dioxide reduction in kilogram. This carbon dioxide reduction is done on comparing this the steam generation process with a typical diesel operating boiler. The boiler also uses diesel to generate the steam, and we are using the diesel and the waste combination to generate the steam. So after our capacity was calculated from the capacity of our steam generation, the steam generation capacity of incineration was calculated. We have also utilized our model to calculate the steam generation capacity of a diesel boiler. Then we have used all this data to find out this carbon reduction. This is the money savings in US dollar. This represents the daily savings. This is the monthly saving. This is the yearly saving, and this is the landfill reduction in kilogram. So all this all this is a brief representation of the calculation that we have done throughout our work. So in conclusion, I would like to say that the proposed model and the case study the analysis shows that the waste to energy has enough potential to cover a significant portion of the total energy requirement of a pharmaceuticals industry. So we have reached to the end of our presentation. As our presentation is about to conclude, I will once again like to thank you for giving us the opportunity, and hope that this activity has given you a much clearer understanding of waste to energy production through the incineration process for the pharmaceutical industry. Thank you for giving the opportunity once again. Take care.